Hi, Adrian. I'm glad you reached out about this because I wanted to kind of create a video, and I think if you don't mind, I'll share this with the whole class. So your question was about the SciBooks activity for the greatest common divisor and Euclidean's algorithm. And this particular activity, the section exercise 4.5.1, says apply the Euclidean algorithm and the extended Euclidean algorithm. So the extended algorithm is going to give us a linear combination of the values, and the regular Euclidean algorithm is going to help us find the GCD. So we're trying to find the GCD of two numbers, 153 and 117. 117. Okay. So we know that we need to divide 153 by 117, right? And so when we do that, we know that 153 is equal to 117 times 1 plus 36. Okay, so if you do the math, that's what you get. Then now what we do is we say, okay, now let's take 117, and how many times does 36 go into 117? So we do 36. Turns out it goes in 3 times, plus 9. Okay. And then the last thing we do is we take the 36 and we say 36 is equal to 9, in this case, times 4 plus 0. And once we get to 0, we know that we're done and that the number right before it is our GCD. So now I know that the greatest common divisor between the two is 9, which means if I had done some prime factorization, I would see that the only numbers that they have in common would have been 3 squared would be the smallest of the two. But 3 squared represents the value that is the greatest common divisor of those two numbers. All right, so next we're going to do the Euclidean algorithm. And what I'm going to do is I'm going to use a approach that I found online, and I'm going to share that video with the class as well. So I'm not going to review the approach. I'm just going to go ahead and show you the example of how it works. And then you make sure you take a few minutes to watch that video. All right, so the way it works is it says, okay, start with the last line before you get to 0, and you're going to solve for the value 9, which is our GCD. So we start by saying that 9 is equal to, so I'm going to subtract 36 times 3 from 117. So I get 117 minus 36 times 3. All right, because I want my linear combination to be something times 153 plus something times 117, I'm going to go ahead and simplify this equation to say 117 plus 36 times minus 3. Okay, same thing as the line above it. It's just some algebra. Okay, the next thing I'm going to do is I'm going to substitute 36 using the next line up. So I'm going to solve for 36, and I'm going to substitute that in. So I still have my 117 plus, and I'm going to use a parentheses. So instead of 36 this time, I'm going to do 153 minus 117 times 1. Okay, and then this whole thing needs to be multiplied times minus 3, because I have this minus 3 up here. So this replaces the 36, this part right here, right? All right, let's do some algebra just to simplify things again. So 117 plus, it looks like I'm going to have 153 times minus 3. And then if I distribute the plus for the 117, distribute the negative sign over to the negative 1. So then I'm going to have plus 117, and I have negative 1 times negative 3, which is going to give me a positive 3. All right. If anybody needs to, I can, here, I'll just do it over here. Let me just do the steps that I kind of glossed over there, but it's 117 plus 153, and if I do plus 117, then I can do times minus 1, and then this whole thing is minus times minus 3. And so then when you distribute the minus 3 here, you get positive 3. Here you still get negative 3. So 117 plus 153 times negative 3 plus 117 times positive 3. All right, now I can combine my like terms. So I'm going to combine 117 times 1 plus 117 times 3, and I get 117 times 4. Okay? And then from there, I also have plus 153 times minus 3. So here is a linear equation of the two numbers. So this is the final answer, and this is what you would see in SciBooks, but this is the final answer for what is the GCD and the extended equation, the linear equation. So this is the linear equation, for the GCD, equation for the GCD of 117 and 153. Okay? All right, Adrian, I hope that helps, and let me know if I can do anything else.